Alright, good afternoon everybody. It's once again Ted the Speed Learner, and today we're going to cover Euclid Book 1 Postulates. There are only 5 of these, and then there's going to be a couple of common notations as well, so hang in there, folks. Postulate number 1. To draw a straight line from any point to any point. Boy, this is going to be easy. We're going to draw a straight line from this point to this point. We're going to call this A. We're going to call this B. I know you're like, that's awkward. Oh well. Anyway, to produce a finite straight line continuously in a straight line. Okay. Let's put a point C. Okay. So we produced a finite straight line inside another straight line. Ooh. Okay. To describe a circle with any center and distance. Okay. Well, it's going to be easy. I think. Okay. Alright, this is a circle. We have, let me read this again. We have described a circle, which means we drew it, with any center and any distance. Well, the distance is from here to here, from here to here, etc., etc. Okay. That all right angles are equal to one another. Gee, that's easy. Let's just draw this. Okay. Draw a line like this. Alright, we have 4 right angles. 1, 2, 3, 4. Now what did Euclid say? He said that all right angles are equal to one another. In other words, this is 90 degrees, so is that, so is this, so is that. Woo, that took a long time. Number 5. That if a straight line falling on 2 straight lines makes the interior angles on the same side less than the 2 right angles, the 2 straight lines, if produced indefinitely, meet on that side which are the angles less than 2 right angles. What the heck does he mean by that? Okay, we have 2 straight lines right here. We are going to have another straight line. Let's say we have this. Okay, there's your 3rd straight line. If a straight line falling on 2 straight lines, which that one did, make the interior angles on the same side less than 2 right angles, which this is less than 90 degrees and this is less than 90 degrees. If these lines, and I would imagine it's these 2 lines, if they were produced indefinitely, they'll eventually meet right here. And there you go. Alright, what about common notations? Things which are equal to the same thing are equal to one another. Okay. This is called the transitive property. And I'm sure you've heard this many times. If A equals B, and B then equals C, then A is going to equal C. Well, if A is a quarter, and B is a quarter, and C is a quarter, then A is going to be worth just as much as B, and B is going to be worth just as much as C, so A is going to be worth just as much as C. How does that work? A is a quarter, B is a quarter, C is a quarter. The value of the quarters does not change just because it's A, B, or C. So all three quarters will all be worth 25 cents. Got that? Cool. Let's go on. If equals be added to equals, then the whole are equal. Okay. Let's say you have A and B. A is a quarter, B is a quarter. Now let's say we add a nickel to A and we add a nickel to B. Well, that would be 30 cents here. That would be 30 cents here. You can see that right there. That would be 30 cents here. That would be 30 cents here. And both sides would be 30 cents. There you go. If equals are subtracted from equals, then the remainders are equals. Well, that's simple enough. If this is 30 cents and this is 30 cents, and you subtract a nickel from this and a nickel from that, then A will still be a quarter and B will still be a quarter, and the quarters are always the same amount. There you go. Things which coincide with one another are equal to one another. I'll let you look that one up yourself. The whole is greater than the part. Gee, that's easy. A whole circle is greater than the two semicircles that would be formed if you drew its diameter. Okay? There you go. And those are the 5 common notations from Euclid. Alright, in my next video, I will indeed show you Euclid Book 1, Proposition number 1. Stay tuned.